How come we keep blinking?
Plumbing Basics. Welcome to the Arizona Contractor License Center's study on plumbing. I realize that you probably have many years of experience in the plumbing field. I also realize that what we do out in the field may be different than what the various manuals and code books state. My intent is to familiarize you with some basic facts and formulas that are common for master plumbers and plumbing contractors. To do that, let's brush up on some of the basics. Again, because of your past experiences, some of this may be elementary, yet we're always surprised at how much we forget. Before going into the solutions of problems which apply to plumbing, it's appropriate to review some mathematical basics such as length, height, and volume. Length is a linear measurement of distance from one point to another point.
Has to get it up on the screen.
I think so, but now that should work.
Okay.
Length is a linear measurement of distance from one point to another point. This is a one-dimensional measurement. An area measurement is two-dimensional measurement used to determine the number of units in an enclosed area. It involves the length and another dimensional measurement known as width. For example, a floor tile measures 1 foot by 1 foot and is known as 1 square foot of floor area. It also contains 144 square inches. 12 inches times 12 inches equals 144 square inches. A cubic or volume measurement requires an additional measurement depth and is three-dimensional measurement. A container that measures 1 foot in length by 1 foot width by 1 foot in depth is known as a cubic foot. It contains 1,728 cubic inches. Not all calculations consist of simple squares or rectangles. Areas of circles and volumes of circles or tanks and pipes are frequently needed. To find the area of a circle, calculate the radius, 1/2 of the diameter, square it, multiply it by itself, then multiply it by 3.1416. As an example, we say we have a circle that has a diameter of 3 feet. To find the area it contains, first divide the diameter in half, in this case 18 inches, to calculate the radius. Then square the radius, multiply the radius by itself. 18 inches times 18 inches equals 324 inches. Then multiply that sum by 3.14, which is pi, resulting in the answer of 1,024 square inches of area within the circle. This method of calculating the size of pipe required, for example, how many 2-inch diameter pipes is equal to an 8-inch diameter pipe. Following the directions from what we've just discussed, we know a 2-inch diameter pipe has a radius of 1 inch. 1 inch squared is 1, multiplied by 3.1416 equals 3.1416. A 2-inch diameter circle contains 3.1416 square inches. Likewise, an 8-inch pipe has a radius of 4 inches. Now square the 4 by multiplying it by itself. 4 times 4 equals 16. And then multiplying that number by 3.1416. That equals 50.2656 square inches. To then find the number of 2-inch pipes required to equal the area of the 8-inch pipe, divide the 50.2656 by 3.1416, and you'll see that you need 16 2-inch pipes to equal one 8-inch pipe. Remember the 3-foot diameter circle we discussed a few moments ago? Let's add another dimension to it. A water container is 3 feet in diameter and is 3 feet deep. How many gallons of water will be required to fill it? We've already determined that there are 1,024 square inches of surface area in the 3-foot circle. Now let's add the 3 foot of depth. Always work with the same increments of measurements, so change the 3 feet into 36 inches. 3 feet times 12 inches per foot. Now multiply the 1,024 square inches of surface area by 36 inches, giving us 36,864 cubic inches. How do we change cubic inches into gallons of water? A cubic foot contains 7.48 gallons. This is one of those facts that's carved into granite. Remember this fact. If we take 1 cubic foot and convert it into cubic inches, 12 times 12 times 12, we have 1,728 cubic inches in a cubic foot. Knowing this, we take the 36,864 cubic inches and divide by 1,728 cubic inches, giving us 21.3333 cubic feet of area inside the container that needs to be filled with water. Multiply 21.333 cubic feet by 7.48 gallons, the gallons in a cubic foot, and you will see we need 159.57 gallons of water to fill the container. Water weighs 8.33 pounds per gallon. Water also exerts 0.433 pounds per square inch per foot in height. Add another foot on top of the first and the PSI increases by 0.433 pounds per square inch. A pipe that is 100 feet in height will have a PSI reading of 43.3 PSI at the bottom of the pipe. Every foot of height also added onto it will increase the weight by the same amount. So if you have a 10-foot stacked pipe filled with water, it will exert 4.33 pounds psi at the base of the pipe. Many times a plumbing inspector requires the soil system to be tested by having all openings tightly closed and a 10-foot vertical pipe to be filled with water for a minimum of 15 minutes. This subjects the system to a 4 to 5 psi pressure throughout to verify a leak-proof system. To illustrate this principle, this water tower is 80 feet high. Using the formula discussed previously, water pressure at the base of the tower will be 34.6 psi. 80 times 4.33 equals 34.6. However, the psi at point B will be 25.9 psi, 60 times 0.433. Just as height increases the static pressure of a system, the reverse is also true. A rise in elevation above the water source will decrease the pressure. For example, fire sprinkler systems in tall buildings must compensate for the reduction of pressure due to the change of elevation. Pumps and storage tanks on the higher floors are required to maintain sufficient water pressure. In this illustration, the water main has a reading of 60 psi at the main. At the highest fixture, A, located 70 feet above the main, the pressure has dropped by 30.31 psi. 70 times 0.433 equals 30.31 psi to 29.69 psi. And that's all for now.
That's all, folks.
So is there more pictures, or is that it?
That is it on this one. In other words, that's it. Where's the stop at?